Welcome back to the Microbits Basics course. I'm Helen. Today we're going to take a look at inputs and outputs. An input is information coming into the microbit, something like sensor data or a button press. An output is something that the microbit does, like flashing an LED or making a sound. All computers, from the smartphone in your pocket to the Raspberry Pi to a supercomputer in a lab, use inputs and outputs. By the end of this video, you will learn what inputs a microbit recognizes, see how a microbit takes those inputs, processes them, and creates outputs, and learn how to make a program that takes inputs and creates outputs. Are you ready? So what inputs does a microbit have? Take a look at this microbit. On the front, you'll see two buttons, each of which is an input. An input is information coming into your device from sensors, buttons, or any kind of hardware that's collecting data for processing. On a normal computer, an input might be your mouse, a keyboard, or a webcam. On a microbit, your inputs are the push buttons, a thermometer which detects temperature, a magnetometer which is like a compass, an accelerometer which detects movement, and your Bluetooth and radio receivers. There are also a series of rings along the bottom of the microbit. These are pin connectors which can be used for additional inputs, such as extra sensors, or they can be used as outputs, controlling external devices such as lights, speakers, or motors. All of the microbit's inputs deliver information to the Central Processing Unit, or CPU, where they are processed and used to trigger outputs. So, how can we code our microbit to take information, process it, and deliver outputs? Let's go back to the MakeCode block editor. Remember, this is microbit specific, but there are other ways to code. For example, you can use Scratch for block-based programming, or for the next level up in complexity, you might want to try a text-based language, such as JavaScript or Python. The simplest way to turn an input into an output is by using an input block. Choose the input you want to use, for example, on button A pressed, or a set movement like on shake, then drag it into your coding area. Next, drag the output you want, for example, show string hello, into your input block. And there you have it. We've just turned an input into an output. You may have noticed down arrows on some of your blocks. Whenever you see one of those, you can change the function of the block. For example, from on button A pressed to on button B pressed. Have you ever wondered how the background in your iPhone moves as you tilt it? Or how your phone can register your movements in a game like Just Dance? Well, we're going to make a simple version using the accelerometer on your microbit. The accelerometer will be our input in this case. Go back to the block editor and choose the event handler block forever. Our input can be found in the pink input section. Drag the acceleration block from there to the screen. And our output comes from the purple LED section. Drag plot bar graph of 0 up to 0 block. Slot acceleration into plot bar graph, and change the second value to 1000. Let's see if it works. Wobble the mouse over the simulator to imitate movement. It works! So, what next? Once your code is ready, you'll need to transfer it to your microbit, just like this. Connect your microbit to your computer using a USB cable. Next, choose a name for your file, and press Save. What happens next depends on the type of computer you're using, but they're all pretty similar. You'll need to press Save, and then the code will be saved as a .hex file on your computer, probably in your Downloads folder. Once you've saved the file onto your computer, you can drag and drop your .hex file from the location where you saved it onto the microbit, which will appear as a drive when you plug the microbit in. Your microbit is ready to use when the yellow light stops flashing. If your school uses tablets instead of computers, you can use Bluetooth to send your code to your device. Just visit this website to find out how. So, let's see if it worked. If we hold it very still, you see just one dot on the LED matrix. But when I tilt it, or move it suddenly, or drop it, or throw it in the air and catch it, look what happens. All the lights flash. Pretty cool. So what could we use it for? In my classroom, we've used input from the accelerometer to conduct experiments on toy cars or paper aeroplanes. What would you use it for? Don't be afraid to think outside the box and get creative. So, we've now seen how the microbit, just like any computer, takes input, processes it, and creates output. We've also started to see how the microbit comes alive when you don't just focus on code. You can use it to focus on real-world problems and digital creativity. I'm looking forward to seeing you in the next session, where we'll take a deeper look at how code can help you get creative with the microbit. Happy coding, and I'll see you soon.